So, hello everybody, it's Arctic Jack, and welcome to my tutorial for how to solve a 3x3. And this is really for people who, so the 3x3 is a particularly easy cube. This one turns really fast. I mean, well, it's not a GAN cube, but it's not an actual Rubik's Cube. And if you look at this 5x5, this is actually not easy to turn, but anyways, but 5x5, yeah, I'll save that for another video. But this video is about the 3x3. And so I will be doing a step-by-step procedure on how to do this puzzle, and I will get back to you once I scramble the cube. So the first step you're gonna want to do is the white cross. So as you can see, you know what, here I'm gonna do that. So here what you want to do is you want to have the white side facing up, but then you want to turn that upside down, the whole cube. And then you see to the yellow side, and then you see how we have this orange piece, the orange piece with the white piece under it. You want to make sure that it lines up, and then you just want to turn this, and then you want to turn this layer 180 degrees. And now you can do that, and you keep doing that with every single piece. Now you may encounter something that looks like this, where you have, say, we have the green piece, the green and white edge piece, but we can't actually, do this. We can't line it up. So what you're gonna do is we have the white side facing up, you turn this counterclockwise 90 degrees, turn the white side counterclockwise 90 degrees, turn the right side up, which is to turn the top layer clockwise, and that's how you do it. I have another one here. All right, now we're gonna move on to the next step. So now we're going to be moving on to the next step, where we are going to be solving the white side. And you can see the white, blue, and orange corner piece is graciously inserted itself into here. So anyways, I'm gonna be showing you in two simple algorithms to put the white pieces, the white corners, into their specific spots. So here we've got green, red, and white. So we're gonna slide that over so it's above. So right, green, white. You wanna make sure that that if you do this, it will be inside, it will be in between all three centers. So anyways, so here's the algorithm. You turn the right side up, the top side clockwise, turn the right side down, and this last turn is optional, but it just feels natural for me and probably for everyone. But I mean, for speed cubers, they wouldn't do this step. I'm just ranting. So what you would do is you would just turn the top side counterclockwise, and now that piece is in there. So now, a clever way to know is if the white side is right here, that algorithm will take 1 time. If it's right here, you'll have to do it 5 times. Up here, 3 times. Up here, if it's done here, it means you've already done it, unless if the colors don't match up. If it's here, you have to do it twice. Here, 4 times. But you're probably thinking, what if I don't want to do it 4 or 5 times? Isn't there like some faster algorithm for that? Well, guess what? There is. So I'm gonna do it right here. So you see the white side is on here. So normally you just take 4 times, but here's an algorithm where you will only have to do that twice. Turn the left side up, top side counterclockwise, turn the left side down, top side clockwise. So yeah, you can turn like what you would have to do something 5 times, and you only have to do it once, and somewhere you have to do it 4 times to only twice. It's pretty easy. So now I'm just going to, oh, and here's another one. So now we've solved the white side, and we will be moving on to the next step, where we will be solving the second layer. So for the second layer, this one is so you have to know both of the algorithms we explained in the last step to actually be able to solve the second layer quickly. Oh, by the way, this is the beginner method, which is the only method I know. I don't have a teaching credential, and I definitely don't have a teaching credential in Rubik's cubes, but I am able to teach because you don't need a credential for that. So now what we want to do is for solving the second layer, so we have the red and green piece, so we're gonna move that over to where it lines up with the green. And now what we wanna do is, since red's over here, we wanna move this away from the red. And then, so if you turn it what you do is, so if you turn it counterclockwise, you're gonna do the left-hand algorithm. And then you'll turn it over to the red side, which is the side you turned it away from, and you turn right. You know what? I'm just gonna, all right, so what we're gonna do is, I'm just gonna re-explain this. So red, green piece, move the green away from the group, make it so that this green piece is across from the red piece, So that would mean moving it to the orange, because orange is across from red, green is across from blue, and yellow is across from white. And then what you're gonna do is you're going to, on the green side, turn the left side up, turn the top side counterclockwise, turn the left side down, and turn the top part clockwise. Now, unlike, you would think, wait, but I don't have to do that. You're wrong. You actually have to do it for this one. So, and now what we're gonna do is turn the right side up. So make sure it's going onto the red side. Basically the side that this piece is on, so the side that this piece is across from, you wanna make sure that you're on that side. Well, not orange side, so we know that orange is across from red. So the top piece, the color that is, you want to be on that side. So if it was orange, I would be on the orange side, green side. But since it's red, I'm on the red side. And then you're going to do the right-hand algorithm. Turn the right side up, turn the top side clockwise. Here, I did that too fast. Turn the right side down, and then top side counterclockwise. Now that time you don't actually have to do it, but I'm doing it because it's simple for me. And now, let's see, we have another one where this will be simple. I'm gonna do something real quick, off camera. Yeah, I'm done with the off-camera work. So, now let's see. We have orange and blue, and so we're gonna turn this away from it. And no, you will not do this algorithm. What you're going to do is, you're going to do it in the reverse order. Turn the right side up, top side counterclockwise, turn the right side down, and the top side clockwise. But actually no, when I said counterclockwise the first time, I meant clockwise, and when I said clockwise, I meant counterclockwise. So yeah, turn the right side up, top side clockwise, turn the right side down, turn the top side counterclockwise. And then you do the left-hand algorithm. Left side up, top counterclockwise, left side down, right clockwise, top clockwise. So, and now we're going to do the other one. And now you may get to a point where you have the edge piece in, but it's not permuted correctly. It's flipped the wrong way. There are two causes for this. One, it was already in there when you found it, and two, it's because you put it in that way. I'm gonna try something first. So yeah, that didn't work, and I just screwed up the cube, because I'm an idiot. Sorry about that. I was trying to do something neat. Trying to get it back in the way it was. Sorry. So anyways, what you're gonna do is, you can start from any side. So I'm gonna do this. So what you do is, you do the same thing for when you want to put a piece in. So, because you can't fit two edge pieces in the same edge slot. So when you put the edge piece in, you're also taking the one out. So for this is an example when you need to take it, when you're gonna notice that you're taking it out. And now we've taken that edge piece out, and now we can just solve it normally. All right, now that we have solved the first two layers, or F2L, but F2L is actually a method for solving the first two layers really quickly that I don't know. I'm probably gonna learn it sometime after I'm done making this video. Here, I'm gonna move my stuff out of the way. Not that I need it to be out of the way, but just for sake of simplicity. So now we're gonna be solving the top cross. The top cross is different because you have to not break the white cross or the white side at all. So what you're gonna do is, I made it so that I have only the no edges showing up. You may have, so here's the thing. You may have two edges show up. You may have no edges showing on the top. You may have two edges, or you may have all four edges, but you will not have one edge, and you will not have two edges. You will not have three edges. Sorry. That only happens on 4x4, 6x6, and above, and that only happens on cubes that have that are even, like 2x2, like 4x4 and 6x6. Like that's an even number above the 2x2. So anyway, so what you're gonna do is you're gonna take this, you're gonna turn so I'm just on the orange side, so you want to turn the front side clockwise and do the right hand algorithm. And now you will have a backwards L shape. So you want to make sure that you can actually see, you have an L shape. Now you want to make sure that what you are seeing is the backwards L shape. You do not want to have the L shape, because otherwise you're doing it incorrectly. So you want to make sure that these two edge spaces are close. So then you're gonna oh, by the way, always remember that after you do that, you have to turn the right side down. So then after you're here, turn front side up, clock up, U prime, and then F prime, but anyway, so yeah, right side up, top side, right side up, sorry, front side clockwise, right side up, top side clockwise, right side down, top side counterclockwise, left side counterclockwise, and now you'll have this, which is a bar. You can ignore the corner pieces. We're not there yet. So now what you're gonna be doing is you just do the same thing again from either side as long as it's still a horizontal bar. If it's a vertical bar, you can't do it. It has to be a horizontal bar. Sorry, I did it a little fast, so. And there you go. You have now solved the top cross. So now what you're gonna wanna do is, we are going to be basically we're going to do what is called so it's called OLL, which is orientation of the last layer. So, usually when you hear OLL, you usually hear it as OLL parity. Just as when you hear PLL, you usually hear it as PLL parity. But those can't happen on a 3x3 or a 5x5 or a 7x7 or any odd number cube. Anyways, enough of that. So what you're going to want to do is you're going to want to look around. So either you will always have one side correct, two sides correct. So you'll either have all of the edges oriented, whereas the red and the green would be switched, and you could just skip this step, or you'll have two, which will either be adjacent or they will be across from each other. Now, no matter how you turn it, you will always have one show up in which you can do this algorithm anywhere. Now, if they're sideways, you'll do the algorithm, turn the top side 180 degrees, so if you ever get to where the top side, there are only two edges are correct and they are across from each other, in that case, you have to make sure that you do this algorithm where the bar would be horizontal, and then after you do it the first time, if you do it correctly, you will be able to turn it until you see two corner edges adjacent to each other. Anyways, enough ranting, now onto the algorithm. So what you're going to want to do is turn the right side up, turn the top side counterclockwise, turn the right side down, turn the top side clockwise again, turn the right side up, turn the top side twice, counterclockwise or clockwise, I do counterclockwise, and then turn the right side down. And it seems that I screwed up. So, by the way, I know where I screwed up. So, when the edges are adjacent to each other, you want to make sure that it looks like this. Now, remember, you can always pause the video if you need more time on something. And also, basically, yeah, all right. Now, all the edges now OLL is complete. And now we're moving on to the next step. So now we're on the second to last step, which is the permutation of the last layers, which means we're going to be putting the corners in the right places. Now, three things can happen. Either all of the corners are in the right spot, which you can just skip this step. One corner is in the correct spot, or no corners are in the correct spot, which you can do this. Or no corners are in the right spot, in which you can do this algorithm anywhere. And you're probably thinking, wait, but I can move it so that a corner is in the correct spot. You can do that, but you'll be breaking the edges. So we're gonna look around for one. Here's one. So you're gonna wanna follow this algorithm also make sure the corner that is correct is on the top right corner. So you're gonna wanna do this. Turn the right side up. Turn the right side up. Turn the top side counterclockwise. Turn the left side up. And turn the top layer counterclockwise. And then turn the right side counterclockwise. And turn the left side down. Turn the top side counterclockwise, sorry. When I said that turn it counterclockwise, I meant turn clockwise. So then you turn the top layer counterclockwise, and then you turn the right side down. And then if the corners aren't in the correct spot, just do it again, and they should be there. Yeah. All right, and now we're going to move on to the next and final step.